Alright, chapter 1 was about real numbers, and remember, we looked at real numbers in terms of infinity. We ended the lesson looking at a number line. We looked at inequalities, we looked at absolute value inequalities. A number line contains all real numbers. You could have 0, you could have 1/2, you could have 1, you could have square root of 9, square root of 8, or square root of 7, but we just looked at values for x. As we move into chapter 2, now we're going to look for solutions that work in two variables, x and y. And really we're going to be looking at different types of functions and graphing those functions on an xy coordinate plane. But before we can do that, we have to take a look at what identifies something as a function. And we start doing that by looking at what is a relation. A relation is just a set of input and output values, often thought of as x's and y's. We could say often thought of. Why don't they just say x's and y's? Because as we start moving into higher level math, it's not always called x and y. You might have an input like A and an output B. But a relation is just a bunch of inputs and outputs. Example, you might have something like an input and output 1, 2, 1, negative 3, 3, 4, 5, 6. You have a number coming in, that's the first number, and then a number coming out, that's the second number. So as you can see, as we start to graph these numbers, we need an xy coordinate plane. So let's try this example and let's graph this relation. So we're going to graph the points negative 3, 3, all these that you see. Quick reminder, back from Algebra 1, you have an xy coordinate plane has an x-axis that goes left to right, a y-axis that goes up and down. When you start graphing your ordered pairs, you start with the x and then go to the y. So looking at an x value of negative 3, starting on the x-axis, we're going to go left from 0, negative 1, negative 2, negative 3, and then up along the y-axis to positive 1, 2, 3. So that's our first point, negative 3, 3. Our next point would be 2, 2. So I'm going to go right 2 units from the origin on the x-axis, up 2 units. 2, 2. Negative 2, negative 2. So along the x-axis from 0, I'm going to go negative 2, then down along the y-axis to negative 2. So there's negative 2, negative 2. 0, 4, along the x-axis, I'm going to go 0, but along the y-axis, I'm going to go up 4. 1, 2, 3, 4. So there's the point 0, 4. And the last point, 1, negative 2. So from the origin, I go along the x-axis 1 and down to the y-axis negative 2. So here is 1, negative 2. So this is a relation. It's a bunch of input and output values. That's why we're moving to the xy coordinate plane, because we're not just looking at values of x. Now we're looking at values of x that are paired with an output value like y. So since we're going to have a lot of input and outputs, we're going to have two sets of categories. The domain is generally the x coordinates. It's the inputs. So you could say inputs. It's the numbers you start with, the numbers going in. If you're listing the domain from a relation, you just list the order of x's from smallest to largest, but you only list every number once. So if I look at my x's, I have negative 3, 2, negative 2, 0, and 1. The smallest number would be negative 3. The next smallest number is negative 2. The next is 0, and then I have 1, and then I have 2. And now I've listed the domain. The range are the y-coordinates, or also known as the outputs. In the same way, I'm going to list my output values. I have 3, 2, negative 2, 4, and negative 2. Notice I have 2 negative 2 values right here in the y's. I only list that once. So my smallest y value is negative 2. My next highest y value would be positive 2. My next highest would be positive 3, and my highest y value is that positive 4. And so there would be my range. Okay, try the next example. Write the ordered pairs for the relation, and then find the domain and the range. So we just did that. Go ahead and try this one here, and when you're finished, go ahead and look up at the screen. Okay, go ahead and take a look at that. The domain, you should have in order, -4, -3, -2, 2, and 3. The range in order, hopefully only listed -2 once, even though it occurred twice. Or, excuse me, hopefully you only listed, ooh, I forgot it, the number 4 once, even though it occurred twice. So you should have -4, -2, 2, and 4. Okay. That's a relation. It's a bunch of input and output values. The next thing we take a look at is what makes a relation a function. And in order to show how a relation comes into being a function, you have to know how to set up what's called and I know this is kind of hidden, but it's called a mapping diagram. That's what this piece is called. A mapping diagram helps you map your domain to your range and identify a function. First, let's see how do you create one. You start by listing your domain vertically up and down and start with the smallest value x can be and end with the largest. So if I look at this relation listed, I have domain x values of -1, 1, -1, and 1. I only list them once, so I list -1 and 1. And then I do the same for the range. The range contains values of 3 and 7. So I go ahead and I write 3 and 7, and then I map the pieces together. So right now, -1 is mapped with 7. So I just draw an arrow saying -1 goes to 7. 1 is mapped to 3, so I draw an arrow saying 1 to 3. 1 is also matched with 7, so I create another arrow. And then -1 is also mapped to 3, so I create another arrow. And that's a mapping diagram. Okay, how is that helpful to us? Well, let's flip it over and we'll see the other side. A function, which we're going to be working a lot with, is a relation in which each element in the domain is paired with exactly one element in the range. So every x value has to have only one, or exactly one, y value. So if you're looking at a mapping diagram, it's easy to determine what a function is based off of what we see. Determine whether the relation is a function. Here, we have the domain x value of -3, and it's mapped to the number 4. It's also mapped to the number 5. That cannot occur in a function. So this right here, if you have 2 arrows coming from one x, this makes this not a function. A function has to have one x mapped to one y. So this here would say, no, this is bad, this does not work. I like to take a look at it as, I think of the Bible verse, no one man can have 2 masters. If you see that happening, one x having 2 different y values, that's bad. That means it's not a function, just like it's bad in the Bible. And you cannot serve both God and money, you cannot serve 2 masters. So you're not functioning right, in my opinion. Looking at the next example, I'm sorry, I don't know what happened with Microsoft Word, but go ahead and cross this off here. That was supposed to be down here, going from 3 to, and let's make another number like 6. 3 to 6. So if you have white out, white that out. But that line, I apologize, is not supposed to be there. So I'll go ahead and white it out since I have that here. All right, if we take a look at this mapping diagram, 2 is mapped to -2, 4 is mapped to -2, 3 is mapped to 6. Every x only has one y value. 2 is only mapped to -2. 4 is mapped to -2, and 3 is mapped to 6. Every x has one output. There's no two arrows coming from the same x. So yes, this is a function. Now you might be thinking to yourself, but wait a minute, this is shared by a y value. That's okay. A function, as defined, just has one x mapped to one y. And that's going to become more clear as we start looking at more functions. Functions are studied all over the place. Like farmers will study how much apples their trees are producing to help them get the most out of their crops. And they'll take a look at, this tree produces, 200 apples, this tree produces 250, but every tree can only produce one set amount of apples. And then they start taking a look at, well, what's the best way to structure where the trees are located so we can get the most products. Okay, I don't like that this was copied wrong, so let's go ahead and create another example. So go ahead and just call this like example 3. I'd like you to create a mapping diagram and determine if the relation is a function. Here's my relation. 1, 0, 2, 3, 4, 5, and 6, 0. Okay, so create your mapping diagram and then tell me yes or no if it's a function. And you can try that on your own and then go ahead and take a look back up here. Okay, hopefully you said yes, this is a function because every x only has one arrow coming from it. Every x has exactly one y. Okay, that's an example of how to complete that piece. Now let's see, we know that we can take these and graph them on an xy coordinate plane. So what if you're approached with a graph? You can't make a mapping diagram because there's infinite points on a graph. So instead, we need a better way to determine how is this truly a function. And it's called the vertical line test. If a vertical line passes through 2 or more points on the graph, then the relation is not a function. Use the vertical line test to determine whether this graph represents a function. So what you're going to do is you're going to take a vertical line, which is up and down. You're going to place it kind of like a laser all the way across the function, which is the shaded part, and see, does that vertical line cross the function more than once? You could even draw it if you want. If I try to draw a vertical line here, it only crosses it once. If I draw it here, it only crosses it once. If I draw it here, it only crosses it once. No matter where I draw the vertical line, it only crosses the function once. So that means, yes, this is a function. The vertical line only crosses the function once. Let me show you an example of how something might fail the vertical line test. If I create an xy graph, x, y, And if I had a function that looks like this, and I'm going to actually draw little points in here. 1, 2, -2. If I have a function that looks like this, you are going to see that this is one of the things we look at. Why would this not be a function? And hopefully you're saying, well, if you draw a vertical line, it crosses twice, here and here. This would be an example of failing the vertical line test. So this would be not a function. Let's think about why this is true. If I labeled what those 2 points are that I bolded in, this would be the point 1, 2, and this would be the point 1, -2. Think about your mapping diagram. I have an x of 1 being mapped to both -2 and +2. That's similar to this scenario right up here. An x value would be mapped to 2 different y's. So that would be bad. I would say, no, this is not a function, and we can quickly test that by drawing any vertical line, and if it crosses the function more than once, that's what makes it not a function.